Okay, this is the Unit 3 review. I'm going to do one of each type of problem. I'm going to move kind of fast. So the first one, we're going to solve this system here by elimination. Remember, when we're solving a system of equations, we're just finding the point at which two lines intersect. So I transferred it over here. Negative 4x plus 6y equals negative 12. I'm just going to make sure I transferred it correctly, and negative x minus 5y equals negative 16. Negative x minus 5y equals negative 16. Okay. So there are a bunch of different routes you can go to solve this problem. I'm going to do the one I'm going to assume most of you chose. I'm going to multiply this by negative 4. And in doing that, so let's just transfer this equation over. In doing that, this becomes 4x, and I can eliminate the x variable. Negative 4 times negative 5 is 20. And negative 4 times negative 16 is 64. So now I'm going to get 26y is equal to 52. And so y is equal to 2. Let me just make sure I did all that math. So 64 minus 12 is 52, divided by 26 is 2. Okay. So again, all I did was I added these two equations together. So negative 4x plus 4x is 0. 6y plus 20y is 26y. Negative 12 plus 64 is 52. Solved for y. Then what I can do is I can go back into one of my original equations and plug in that y value. So let's just do the top value, or the top equation. So negative 4x plus 6 times 2 is negative 12. So negative 4x plus 12 is equal to negative 12. I'm going to subtract 12 on both sides. So negative 4x equals negative 24, and x is equal to 6. So my solution to this system is at the point 6, 2. All right, now we'll do number 6. So we have to solve this system by substitution. Same thing, we're just trying to find the point at which these two lines intersect. So I transferred the problem over to here. Now I already know what y is equal to. Okay, I know y is 2x minus 10. So what I can do is I can just take this y value and plug it in here to solve for x. So what that looks like is 3x minus 7 times the quantity. Now I'm going to take this and plug it in here. So 2x minus 10 is equal to 37. We're going to distribute that 7. So 3x minus 14x plus 70 is equal to 37. I'm going to combine like terms here. So that's negative 11x. And then I'm going to subtract 70 from both sides. Is equal to negative 33. So x is equal to 3. Now what I can do is I can take this 3 value. Uh-oh, I think we froze up a little bit. Here we go. There it is. Okay, what I can do is I can take this x value and I can plug it in to this y equals equation to find out what y is. So I can take y equals 2 times 3 minus 10. So that's 6 minus 10, which is equal to negative 4. So my answer is the point 3, negative 4. Okay, here is one of our word problems. For these word problems, there's always going to be two variables that you're going to have to identify. In this case, we have bracelets and necklaces. So I'm going to call x the number of bracelets. And I'm going to call y the number of necklaces. Okay, so you can kind of skip ahead and see the jeweler made a total of 12 bracelets. So I know the sum of bracelets and necklaces has to be 12. X plus Y equals 12. And then they say the amount of gold in each bracelet is 5 grams. So 5X and 24 grams for the necklaces plus 24Y. And it totals 155 grams of gold. Okay, so I'm going to transfer this system over to Microsoft Word so I have more room to work. So I think it would be easiest to solve this by elimination. You can also do substitution. If I subtract x from both sides, for example, you have a y equals. I'm going to multiply this by -5. So we end up with -5x minus 5y equals -60. This will stay the same. So 5x plus 24y equals 155. If we add these together, we end up with 19y equals 95. And then if I divide by 19 on both sides, I get y equals 5. And then I'm going to take that y equals 5 and I'm going to plug it in or substitute to solve for x. So x plus 5 equals 12. So x is equal to 7. So in this case, we're going to have 7 bracelets and 5 necklaces. Okay, when we're solving a system of inequalities, we're looking at 16 now. What we're going to do is graph both boundary lines and then see where the shading overlaps. So if I'm graphing these boundary lines, here my y-intercept is at -5, and my slope is -1. So I'm going to go down 1 over 1, down 1 over 1. And because it's y is greater than, I'm going to use a dashed line. The second one, my y-intercept is at -8. So that's my first point. And my slope is 2x, so I go up 2 over 1, up 2 over 1, up 2 over 1. And again, because y is greater than, or sorry, less than and not less than or equal to, I'm going to do a dashed line. Okay, so for the first line, this is my line number 1 and this is line number 2. It says y is greater than, so I'm going to have to shade above. And for my second line, it says y is less than, so I'm going to shade below. So the point of overlap here, I'm going to shade above, and below is going to be this region right here. And that would be your answer showing graphically how two systems overlap. Okay, this is looking at stuff using matrices. So what this is telling us for matrix C, tell us the matrix element for C1, 2. The 1 tells us the row. The 2 tells us the column. So row 1, column 2 is -3. So you would say C1, 2 is -3. These are quick, so we can look at one more. A2, 3, that's row 2, column 3. Row 2, column 3 would give us -2, so A2, 3 for this one is -2. If we're going to write a matrix to solve this system, we can call the matrix whatever we want. Let's just call it matrix A. Basically, all we're doing is we're going to put in the coefficients and then the constant. So the constant is always furthest to the right. So this would be 3, -5, 10. So that's 3, -5, 10, and then 2, 10, and 20. 2, 10, 20. That's it. Solving on your calculator, I made a video on this already. This one doesn't work out nicely, so if you want to skip that one. For number 28, if we're making a matrix here that you're going to put in your calculator, it would look like 1, -1, 1, 0, 1, -2, -1 and 5, and then 2, -1, 2, and 8. If you're solving this one, you end up getting 14.5, 8, and -6.5. I made a separate YouTube video again on how to do this on your calculator, so I'll direct you to that if you're having trouble putting this into your calculator. There will be a 3-variable solve the system problem. You will get whole numbers for your answers. I've given you tons of examples of those, so you can look back at those to do some review. But that's pretty much it. It's pretty straightforward. A lot of it is these problems can end up taking a long time just because there's a lot of steps.